So in last lecture, we were talking about the quantiles and the sample quantiles. If a random variable x has the distribution function capital Fx with probability function that is small fx, then a pth quantile, it is also known as a fractile, denoted by xi p, then xi p is defined as probability x less than or equal to xi p is equal to p. If you are talking about the pth quantiles, then probability of x less than or equal to xi p is equal to p, then we say that the xi p is the pth quantiles, and probability of x exceeding the xi p, it is equal to 1 minus p. Then xi p is nothing but, you can write in that way, probability of x less than or equal to xi p. So it is nothing but the cumulative CDF, or its cumulative distribution function. We denote as a capital Fx. So it is a capital Fx of xi p. And this is nothing but we have say it is a p. So if we take p equal to half, then xi half is called the median. If you take p equal to 1 by 4, then xi 1 by 4 is said to be a Q1, first quartile. And if you take p equal to 3 by 4, then xi 3 by is said to be a Q3, that is called the third quartile. So depends on the value of p. P is equal to half, then xi p is median. P is equal to 1 by 4, then xi p is Q1. P equal to 3 by 4, then xi p is Q3. Okay, so we will obtain the distribution of the, because our basic idea is that we are interested to obtain the distribution of the sample median. Xi p is said to be a population median. Okay, so let us have a definition. If x1, x2, xn is a random sample drawn from a distribution function capital Fx, and if x1, x2, xn order statistics are corresponding order statistics, and if 0 less than p less than 1. Why it is a p is lies between 0 1? Because we are talking about the cumulative probability, and cumulative probability is always lies between 0 to 1. So that is nothing but the p, and p is lies between 0 1. Then the pth sample quantiles denoted by the zp is the kth order statistics. Okay, so when you say that the pth sample quantiles is a nothing but it is a order kth order statistics, where k is nothing but np. If there are n number of observation, and if you are looking for the pth quantile, then np, if np is an integer, then you have to arrange the data in a ascending orders, and you have to find out the npth observation that is giving the your pth quantiles. And if np is not integer, okay, then you have to find out the box np. Box np is nothing but it is taking the greatest integer value. Suppose np is equal to 2.5. So what is the box np? Greatest integer is, it is a 2, which is less than or equal to np. So if np is not an integer, then the kth order statistics is nothing but the box np plus 1. So that means what is your sample median or the sample quartiles or the pth quantiles? It is nothing but np plus 1. That means it is a 2 plus 1, that is called 3. So whatever the value of the third order statistics, that is nothing but the pth quantile. So here there is a small mistake. If you are looking for the finding the median, if you are talking about the median, so this is for that. If np is odd, then if np is odd, then it is not the equal to, np is odd, then the median is nothing but np plus 1 by 2th observation. So that means zp, p is equal to half, then it is nothing but x of np plus 1 by 2. And if np is even, it is nothing but x of np by 2 observation plus x of np plus 1 by 2 observation divided by the 2. So that is called the nothing but the median. Okay. So when it is saying to be median, if I am taking the p is equal to half, if I am taking p equal to half, then what is the median? That is the simple median. Z half is nothing but, or population median is a xi half. It is nothing but the x of np by np. That means it is a n by 2th observation plus, if x is even, it is a n plus 1 by 2th observation. Okay, divided by 2. So here, if you are writing the ZP, this 2 is not there. There is no need of 2. Okay. Here it is also not required. It is simply a NP plus 1th observation, and here it is a NP plus x NP plus 1 by 2th observation divided by 2. So you have to make the small correction over here. If this is for the even, and for odd, it is simply z half is nothing but x of n plus 1 by 2 observation. Okay. It means that, what did it say? It means that if we are talking about the fifth order statistics, fifth sample time, it is a NP plus 1. Okay. And for E1, it is a NP plus NP plus 1 by 2. Okay. So I am interested to find out the distribution of asymptotic distribution of the sample quantiles. So this is the theorem we are trying to prove the results. Let x1 x2 xn be a random sample drawn from a distribution function fx. Fx is a non-decreasing. Non-decreasing means, when you said that the function is non-decreasing, when fx takes greater than the 0, if you take the second derivative or the first derivative of f with respect to x, it is always greater than 0, then you can say that the function is a non-decreasing given a value of x. And PDF is greater than equal to 0. So if you take the derivative of this, it is nothing but the greater than 0 for continuous distribution. And let x1, x2, xn be the corresponding order statistics. So we said that x1, x2, xn are the corresponding order statistics. Then the speech sample quantile ZP is asymptotically distributed as a normal with mean xi p. This is the mean xi p. And population quantile, and the variance as p into 1 minus p upon n f of xi p whole square. Okay. So if Zp is a sample quantiles, then what we trying to prove that Zp is distributed as normally, asymptotically normally distribution with the population quantiles whose mean is Zp and variance is this p into 1 minus p upon n into f of Zp square. So that we wish to prove. So how to prove that? So let us we prove this result for the sample median. This is the general setup. If you take p equal to half, it is giving the sample median. So xi half is a population median defined as, when you say that xi half is a population median, तो हमने बताया था कि xi p is said to be a population with quantiles if f of xi p is equal to, you can write p. If I am writing that xi half is a population median if f of xi half is nothing but 1 by 2. So that is what it is written. Xi half is a population median defined as f of xi half is equal to half. Let I am assuming that xi half is nothing but theta. Okay. Anyone has problem to enter? No? Unable to join. अभी ज्वाइन हो पा रहा है ज्योति?
यस, हम लोग एक्चुअली ग्रुप में मैसेज कर रहे हैं कि हमें ज्वाइन क्लास आ रहा है, वो सर को एक्सेप्ट करने बोलो करके।
अच्छा, वो क्या है, लेट आते हैं ना, तो ये एक बार मुझे लग रहा है कि रिकॉर्डिंग शुरू हो जाता है उसके बाद अलाउ नहीं कर रहे हैं।
नो, इट वाज लाइक कि आपने जो मेल हमें भेजा है ना, उसमें हमारा मेल आईडी मेंशन है, इसलिए हम डायरेक्टली ज्वाइन हो पाते हैं अगर हम लेट भी होते हैं तो, लेकिन उनका शायद मेल मेंशन नहीं है, इसीलिए
ओके,
उनको नहीं कर पाते वो ज्वाइन डायरेक्टली।
ठीक है, वो अभी एक दो दिन में मेरे पास फाइनल आ जाएगा ना कितने स्टूडेंट्स है, क्योंकि कोई एंटर होता है जाता है आता है। तो वंस दैट लिस्ट इज फाइनल, फाइनल हो गया है, तो अभी मेरे पास उसका ईमेल आएगा, तो फिर आई विल ऐड एवरीवन, फर्स्ट रिमूव एवरीवन देन ऐड एवरीवन, सो दैट देयर इज नो इश्यू।
हाँ, फिर वो इशू नहीं होगा।
ठीक है, तो अभी हम शुरू करते हैं, आगे बढ़ते हैं। तो xi half is a population median defined as a f of xi half is equal to half. Let I assuming that xi half is equal to theta, then small fx of xi half is nothing but small fx of xi half is, I am saying the theta, and it is nothing but, let us say, y0. I am calling it as the y0. Okay, so what I am assuming, xi half is theta, okay, and f of xi half, I am saying it is a y0, and f of xi f is nothing but f of theta. So wherever the f of theta, I am saying it is a y0. Now let us expand capital F of x tilde. Suppose if I am saying that x tilde is nothing but the sample median, okay, then I am trying to expand f of x tilde around the f of theta. यूजुअली हम कहते हैं ना कि x को उसके मीन के आसपास एक्सपांड करते हैं. A function of x is expanded around its mean. So how to expand this? So we will use the concept of a Taylor series expansion. Here the theta is nothing but your population median, and x bar is said to be a, x tilde is said to be a sample median. It is a sample median. Okay, so I'm doing the expansion of f of x tilde around the f of theta by using the Taylor series expansion. So it is nothing but f of x tilde is equal to f of theta प्लस जिसके आसपास करते हैं उसका क्या रहता है, माइनस रहता है, x tilde माइनस थीटा, देन द फर्स्ट डेरिवेटिव ऑफ fx around the theta, so that is f dash theta plus x tilde minus theta square upon 2 factorial f double dash theta, and so on. So this is where we use the Taylor series expansion. So now if I'm writing f of theta is nothing but, I have taken f of theta is equal to xi half is equal to theta, so f of theta is equal to half, so I'm writing half plus x tilde minus theta, and f dash theta is nothing but the derivative of capital F, and it is nothing but the small f, so small f theta plus x tilde minus theta whole square upon 2 factorial plus f double dash theta plus so on. So what I do, I will just approximate, or you can say that expansion of a first order. So first order, that means I can take up to the linear f of x tilde whose linear approximation is nothing but approximately half plus x tilde minus theta, and f theta I have said it is y0. So rest of the terms I am omitting because this is the quadratic term. Square term is there. It is a quadratic. So I am only going for the linear exponential by using the Taylor series. So f of x tilde is approximately half of x tilde minus theta y0. Is that clear up to here, everyone? The first order
Yes, sir.
approximation. It is said to be a, when I am saying the linear approximation, it means it is a first order approximation. When I am saying the first order, that means the power of x is 1. Whenever you have the power of the x tilde square, that means it is a second order. It is said to be a quadratic. Okay. So we will take the first order approximation. So fx tilde is equal to half of half plus x tilde minus theta y0. Okay, so now this is we have. Now let n be odd. Now there is a question whether the n is even or odd. Suppose we say that number of observation be odd, and that odd is I am saying that n equal to 2m plus 1. Okay, then the sample quantile is the m plus 1th order statistics. तो आगे हमने देखा ना कि when n is odd तो आपका क्या रहेगा, जो भी ऑब्जर्वेशन है आपने बताया ना n plus 1, okay, by 2 when n is odd. So it is nothing but n is equal to, you have taken 2m plus 1 plus 1 divided by 2. So what is that? It is a x of 2m plus 2 upon 2. And what is that? It is a x of m plus 1. So this is what it's saying that. Okay. Then the sample quantile is m plus 1th order statistics. That is, you have to find out x of m plus 1. So arrange the data in ascending orders and find out the observation of m plus 1th order statistics. That is nothing but your sample median when n is odd. Okay, so we have to find out the distribution of, so ultimately now what we wish to find out? I am interested to find out the distribution of sample median. If I am saying that n is equal to m plus 1, that means I have to find out the order statistics x of m plus 1, and that means I wish to find out the distribution of m plus 1th order statistics, that is x of bracket m plus 1. So we know that, what we know, the distribution of order statistics, how many observation, if you remember, suppose this is your x of m plus 1th order statistics. There are total how many observation? Xn, and this is your x1. There how many x precede the m plus 1? So it is a mx precede the m plus 1. And how many m succeeds m plus 1? It is a n minus m plus 1. But what is n? In our setup, n is 2m plus 1 minus m minus 1. So this cancel out, and 2m minus m is m. So how many x precede the x order statistics, x m plus 1 order statistics? It is m. So we have a total observation is n factorial. N observation, it is n factorial, divided by precede observation is m factorial, succeeded observation is m factorial. Okay. Then you have a fx of m plus 1th order statistics. How many x precede this? So there is a m. And how many m succeeding the xm plus 1? So they are also m, and that is how they are, you are writing fx of xm plus 1. So whenever you are trying to find out the distribution of mn plus order statistics, so that is what it is written. And we call them a xm plus 1. This is nothing but our sample median. So it is a n factorial is nothing but we have n equal to 2m plus 1. So it is a 2m plus 1 factorial upon n factorial into m factorial. Fx of sample median raised to m, 1 minus fx of this m, and it is fx of sample median. X plus 1 m plus x of m plus 1 order statistics is written as a fx of sample median. Now what we can write this, we have already obtained fx of f of sample median is equal to approximately half plus x till minus theta y0. So now this equal to become the approximation because we are only taking the first order. So this I am replacing by half plus x till minus theta y0, okay, raised to power m, and this is 1 minus half minus this. The 1 minus half is half, and this is minus the 1 minus x till theta y0 raised to m, and this is we call them as a y0. So I am writing as a y0 because here you can see that fx of theta is nothing but the y0, and here we theta is okay, simple median is y0. So approximately you can have this. Now we can use the Stirling approximation. So we are using the Stirling approximation. Okay, wherever there is a n factorial, we can write it as a root 2 pi n raised to n plus half e raised to minus n. So now I have instead of n, I have a 2m plus 1 factorial. So first I am writing it is root 2 pi. n की जगह पे क्या है 2m plus 1, तो I am writing 2m plus 1 raised to 2m plus 1 plus half e raised to minus n. n क्या है 2m plus 1 into y0, और यहाँ पे क्या आएगा रूट 2 पाई m रेस टू m प्लस हाफ e रेस टू माइनस m. m फैक्टोरियल दो बार है इसलिए मैंने क्या उसका स्क्वायर ले लिया. दिस इज आई एम राइटिंग एज इट इज हाफ ऑफ हाफ प्लस दिस क्वांटिटी आई एम राइटिंग एज इट इज, एंड दिस इज y0. y0 में कहाँ पे यहाँ पे लेके आया, तो आई हैव रिटन y0 हियर, दिस y0. ओके, so now we will try to cancel out possible. तो यहाँ पे अपना रूट 2 पाई है, यहाँ पे नीचे क्या है रूट 2 पाई स्क्वायर दैट इज 2 पाई, तो 1 रूट 2 पाई विल बी कैंसल आउट, तो एक ही रूट 2 पाई बचेगा. यहाँ पे पावर क्या है 2m प्लस 1 रेस टू 2m प्लस 1 प्लस हाफ दैट इज ए 2m प्लस 1 2m प्लस 3/2, तो दैट इज, एंड यहाँ पे क्या है e रेस टू, आपके पास ये क्या क्वांटिटी, इट इज ए e रेस टू माइनस 2m माइनस 1, ओके, ये था, इज इट. यहाँ पे क्या हो गया नीचे e रेस टू माइनस 2m, तो a कैंसल आउट हो गया, तो क्या बचेगा e रेस टू माइनस 1, तो दैट इज हाउ इट इज रिटन एज e रेस टू माइनस 1. और यहाँ पे क्या बचेगा m रेस टू 2m प्लस 1/2, तो बाई 2 है ऊपर स्क्वायर है, तो क्या बचेगा ओनली 2m प्लस 1, तो दैट इज m रेस टू 2m प्लस 1. अब ये मैं क्या कर रहा हूँ, ये दोनों का रेस टू सेम है, तो मैं क्या कर रहा हूँ दोनों को साथ में लिख रहा हूँ, हाफ ऑफ दिस क्वांटिटी हाफ माइनस दिस एंड पावर m0, एंड दिस इज y0 एज इट इज. नाउ जस्ट अगेन यू आर राइटिंग दिस एज ए 2m, तो इसको हम क्या कर रहे हैं, व्हाट वी डू, तो हमने इसको ये वाला जो क्वांटिटी है उसको ऐसे लिखा कि सपोज m टेंड्स टू इन्फिनिटी, m is large, what happened to this quantity 2m plus 1 raised to 2m plus 3/2 add and divide by 2m m raised to 2m plus 1. So limit m tends to infinity, what I can do, क्या कर सकते हैं कोई बताएगा. मैंने दो पार्ट अलग कर दिए 2m plus 1 raised to 2m, limit m tends to infinity 2m plus 1 raised to 2m plus 3/2, वही है ना. divided by m raised to 2m plus 1. So what I did, I have written in this way, limit m tends to infinity. First I am writing 2m plus 1 raised to 2m. This is a 2m plus 1 raised to 3 by 2 and divide by m raised to 2m plus 1. Now is equal to what we can write, limit m tends to infinity. Here what I do, I will just take the 2m raised 2m is a common. So what happened, 2m power 2m is that. So what I can write, I can write this way, 2m 1 by 2m raised to 2m. ओके, और इसकी जगह पे क्या लिख सकते हैं, इनटू, यहाँ पे मैं क्या करूँगा, अगेन एक 2m रेस टू 3 by 2 बाहर ले लेता हूँ, तो ये क्या बचेगा, 1 प्लस 1 अपॉन 2m रेस टू 3 by 2. ठीक है, मैंने जस्ट बाहर निकल लिया. तो और ये क्या हुआ, m रेस टू 2m plus 1. नाउ I can have a limit to this as well as this. तो मैं इसको ऐसे लिख सकता हूँ, m tends to infinity 2 raised to 2m, और यहाँ पे एक जो है वो आ गया 3 by 2. यहाँ पे क्या बचेगा, m raised to 2m plus 3 by 2. ठीक है, इंटू 1 plus 1 upon 2m raised to 2m. ठीक है, और ये क्या बचा, 1 plus 1 upon 2m रेस टू 3 by 2, और डिनोमिनेटर्स में क्या है, m रेस टू 2m plus 1. तो यहाँ पे आपके पास क्या है, m रेस टू 2m plus 3 by 2, यहाँ पे 1 है, तो ये कैंसिल आउट हुआ, तो क्या बचेगा वहाँ पे, लिमिट m टेंस टू इंफिनिटी 2 रेस टू 2m plus 3 by 2 and m raised to half. M raised to half is nothing but root m. And if you give the limit to this, so what happen, limit 1 plus 1 upon 2m raised to 2m, when m tends to infinity, it is a e. And what about this, as you can take m inside, limit m tends to infinity, 1 upon 2m goes to 0, so 1 raised to 3 by 2 is 1. Okay, so why, because we have used this limit x tends to infinity, ऐसा है,
Yes.
1 plus 1 upon x raised to x is equal to e. ऐसा ही है. So we have used this particular rules and now we have this quantity. ठीक है, and we make approximately. So I can write it that in this way, 2m plus 2 raised to 2m plus 3 by 2 root m e. और ये e raised to minus 1 कहाँ से था, तो ये तो पहले से ही चल रहा था, तो e raised to minus 1 अपॉन रूट 2 पाई, तो e and e raised to minus 1, ये क्या हो गया, 1 minus 1 that is 0, e raised to 0 is 1. तो आपके पास क्वांटिटी क्या बचा, 2 raised to 2m plus 3 by 2 root m root pi. ओके, ये आया. नाउ यहाँ पे आप इसको लिख सकते हैं, तो आप ऐसा हो गया कि x minus a into x plus a, what will you write, x square minus s square. तो यहाँ पे क्या है, प्लस है एंड यहाँ पे माइनस है, तो दिस इज काइंड ऑफ दैट, तो 1 by 2 1 by 2 1 by 4, एंड ये क्या आएगा, x tilde minus theta square into y0 square and power m. ठीक है, so now this quantity I am writing here root m of this, ये 1 by 4 I am just taking outside, तो 1 by 4 raised to m, so it is become 1 minus 4 into x tilde minus theta whole square y0 square raised to v0. But हम जानते हैं, क्या जानते हैं, we further know e raised to minus x is equal to, हम क्या लिख सकते हैं, 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus up to 2. But if I'm taking the first order approximation, then I can write e raised to minus e raised to 1 minus x, this, if I'm taking the linear approximation. So that is what I have used. कि मेरे पास ये है तो मैं 1 माइनस एक्स लिखूंगा तो 1 माइनस ये मेरे पास क्या है 1 माइनस ई रेस टू पावर m. So I can write it as a e raised to minus 4 x tilde minus theta square y0 square. ओके और ये पावर m है तो क्या हो गया मल्टीप्लाई हो गया तो इट इज e raised to minus 4m x tilde minus theta square y0 square. ये y0 जो था वो मैं यहाँ लिख के आया. इज इट क्लियर? ये कैसे लिखा हमने? आई रोट दिस इन दिस वे e raised to minus 4 x tilde minus theta whole square y0 square. उसका पावर क्या है m है so of course we can write is a 4m x tilde minus theta whole square y0 square. So this is what I have and everything is approximation. Okay, so आप देख सकते हैं कि आप कुछ टर्म उसमें से रिमूव करेंगे तो there is no issue. Now what we try to say that suppose if I am saying that 4m y0 square is equal to 1 upon 2 sigma square. So what I can write sigma square equal to ये 2 इधर आ जाएगा तो 1 upon 8m y0 square लिख सकता हूँ. And what is the sigma? It is a 1 upon because इसका स्क्वायर रूट लेंगे तो 3 का 8 का स्क्वायर रूट क्या आएगा 2 रूट 2 रूट m and y0 स्क्वायर का y0. So I am writing sigma as this. So now you can see that 2 रूट m y0 कहाँ बैठा है 2 रूट m y0 कहाँ बैठा है ऊपर. तो ये क्या हो गया 1 upon this is equal to you can have a sigma. तो इसकी जगह पे क्या लिख सकते हो 1 by sigma that means you can write 1 upon sigma root 2 by e raised to. अब ये आपने क्या बताया कि 4m y0 square is equal to आपने क्या बताया 1 upon 2 sigma square. तो I can write it as a 4m y0 square is equal to 1 by 2 sigma square. So it is e raised to minus half x tilde minus theta whole square and ये आपका आ गया. तो ये किसका डेंसिटी है? It is the density of what? Which distribution? It is the density of which distribution?
Normal.
It is a
Normal
normal
distribution.
distribution. So it is the density of normal distribution. तो किसका हम कर निकाल रहे थे approximation? This is a f of x xi. ठीक है उसका हम निकाल रहे थे ना. So it is nothing but it is a small f. Order statistics निकाल रहे थे small f of xi. So it is nothing but the normal distribution. So we can say that x tilde is normally asymptotically normally because approximation so we count them because m tends to infinity we have taken it is asymptotically normally distributed with mean here theta and variance is sigma square. And what is the variance? Theta is nothing but we say it is a xi of half and sigma square हमने क्या बताया sigma square is equal to 1 upon क्या बताया 1 upon 8m y0 square. But if I am saying that approximately because हमने लिखा था n equal to 2m plus 1. Okay, so if I am saying that 4n is approximately I can write it as 8m. ठीक है approximately. So instead of the 8m I am writing as a 4n. So it is nothing but x tilde is this normal distributed as xi half 1 upon 4n y0 की जगह पर हमने क्या पता था it is a f of xi half. So it is a f of xi half whole square and that is what we wish to prove. The sample quantiles is distributed as normal with xi half and 1 upon 4n f of xi half whole square. And if you are saying that if you are looking for the pth quantile, so it has a xi p. and 1 upon 4n f xi half whole square. So that is what the theorem is saying. Then okay, अब यहाँ पे अपने क्या लिखा है 1/4. अब 1/p इज इक्वल टू हाफ है तो क्या होगा ये, इसको आप लिख सकते हैं 1/2 इंटू 1/2. तो 1/2 इज p एंड दिस इज ए 1 minus p. So I can write it as a p into 1 minus p. ये 4 चला गया. So this is what the result. ठीक है? Any questions up to this? So main thing is that to prove this, you have to use the Taylor series expansion and you have to use this Stirling approximation. So just substitute this Stirling approximation, use the Taylor series expansion, use the distribution of the m plus 1th order statistics, and then you can prove that they are asymptotically normal. And one more thing is that you have to use this formula, limit m tends to infinity. So whenever you wish to prove, you do not require to cram it. You have to see that what kind of the steps you have to follow and which results you have to use. If you remember this, automatically you can easily prove the theorem. So let us understand one example. Find the asymptotic distribution of sample median when x1, x2, xn are random sample drawn from a normal mu sigma square and when they are drawn from a Cauchy distribution. So for a normal distribution, let xi half be a population median. So we know that हमने क्या बताया था, f of xi half is equal to half. तो f of xi it is a CDF. तो CDF है तो आप क्या लिखेंगे, minus infinity to xi of half. f of x dx is equal to half. और f of x क्या है, normal density. So I am using it minus infinity to xi of half 1 upon root 2 pi sigma e raised to minus 1 by 2 sigma square x minus mu square. ठीक है. मेकिंग द ट्रांसफॉर्मेशन, तो आप क्या कर रहे हैं, ट्रांसफॉर्मेशन ले रहे हैं कि भाई x माइनस म्यू बाई सिग्मा इज इक्वल टू, यू आर सेइंग दैट t. तो आप उसको स्टैंडर्डाइज में कन्वर्ट कर रहे हैं. तो व्हाट हैपन व्हेन x टेक्स वैल्यू माइनस इन्फिनिटी, t tends to minus infinity. When x takes value xi of half, then t tends to xi of half minus mu upon sigma, and this is 1 upon root 2 pi. Okay, and इसका डेरिवेटिव लेंगे तो d of x क्या आएगा, it is a dx by sigma is equal to dt. So this sigma will be cancelled over there, sigma will cancel out, or you can say that dx of by sigma is nothing but dt. So now it is e raised to minus x minus mu upon sigma whole square, it is a t square divided by 2 root 2 pi dt, and that is equal to half. Now this is nothing but the density of a standard normal, CDF of a normal standard normal. If I am saying that this is the CDF of a standard normal, phi of xi half minus mu upon sigma is equal to half, where phi of x is nothing but this. Since we know that in a normal distribution, if you see the normal distribution, what is the median of normal distribution? It is a 0. So at 0, it is giving the half. The probability is half. Okay. So phi of 0 is equal to half. So that means ये half कब होगा? When this is become the 0. So that is xi of half minus mu upon sigma equal to 0. That means xi of half equal to mu. So in a normal distribution, we know that the median and mean are equal, and that is what it is saying, that median is equal to mu. So now you can just substitute it here, f of mu. What happened? 1 upon root 2 pi sigma. हम निकाल रहे थे ना f of xi half. तो xi half की जगह पे आप क्या कर रहे हैं, mu substitute कर रहे हैं. तो mu यहाँ पे करेंगे तो e raised to ये क्या हो गया 0. तो that is f of mu is equal to 1 root 2 pi sigma. So what is the f of mu square? It is a 1 upon 2 pi sigma square. ठीक है. एंड हमारे पास नीचे क्या था मीडियन में, वेरियांस में 1/4n एफ ऑफ म्यू रेस्ट टू 2, एफ ऑफ म्यू पावर 2। तो 4n एंड एफ ऑफ म्यू इज इक्वल टू क्या लिख सकते हैं, 1/√2 पाई सिग्मा। So this 2 will be cancelled out with this, and this pi sigma square goes up. So it is a pi sigma square by 2n. That means the in a normal distribution, z half is distributed as normally, asymptotically in distribution normal with mean mu, and variance is pi sigma square upon 2n. So many times this kind of a questions may ask in a net or set examination. If x1, x2, xn are a random sample drawn from a normal with mean mu and sigma square, what is the distribution of the median? Okay, so it is nothing but asymptotically normal with mean mu and variance pi sigma square upon 2n. Okay, any questions, anyone up to this? We have, which result we have used? We have used this result. It is distributed as a normal with mean xi of half 1/4n f of xi of half whole square. Okay, हमने यही यूज किया है. Now we wish to find out the distribution of sample median in a Cauchy distribution. So again, the f of xi half is nothing but the half. So we use that. We know that the range of Cauchy distribution is lies between minus infinity and infinity. It is minus infinity xi of half. And what is the PDF of Cauchy? It is a 1/pi 1 plus x minus theta whole square is equal to half. So now again we make the transformation x minus theta equal to, if I am saying that t, here it is written, then dx is nothing but dt. So here when x tends to minus infinity, t tends to minus infinity. When x tends to half, then t tends to xi half minus theta. So that is what it is range. And dt upon pi into 1 plus t square. Now I will take pi this side, so I can write it as a pi by 2, and minus infinity is xi half minus theta dt by 1 plus t square. But we know that what is the integration of 1/1 plus t square? It is nothing but tan inverse t. So that is tan inverse, and what is the range? Minus infinity xi half minus theta, and that is pi. So I can write tan inverse xi half minus theta minus tan inverse minus infinitive. And what is the tan inverse minus infinitive? It is a minus pi by 2. So that is tan inverse xi half minus theta minus of minus pi by 2, that is plus pi by 2. Plus pi by 2 will be cancelled out this, so it is a 0. So tan inverse this equal to 0. If tan is 0, that means this quantity is 0. And this quantity is 0, that is xi half minus theta equal to 0. Then xi half equal to theta. That means population median is nothing but the theta in a Cauchy distribution. Now what is the variance of a population median? Because we have this formula, it is normally distributed with mean xi half here theta, and variance is 1/4n f of xi half whole square. Now f of xi half, that is nothing but f of xi half is nothing but f of theta, and जहाँ जहाँ पे x है वहाँ पे आपको थीटा रखना है. So what is the 1/pi? It is 1 plus x की जगह पे थीटा रखो, थीटा minus थीटा whole square. So this is 0, so it is nothing but 1/pi. तो आपको क्या सब्स्टिट्यूट करना है? Wherever there is f theta, you have to substitute pi. So it is nothing but 1/4n So, any question to this? Anyone? Hello.
No, sir, no questions.
Okay, because my internet gone, so I have joined with the mobile. Uh, any issue with the previous two? Because we have seen two example. I think up to that you have seen the internet.
तो सर जस्ट वन थिंग आपने जो लिखा था उसमें कुछ वन माइनस वन प्लस थीटा होल स्क्वायर ऐसा कुछ था और
हाँ,
जो बुक में था
तो
वो थीटा माइनस थीटा स्क्वायर ऐसा कुछ था आई गेस.
वो एक्चुअली जहाँ अपना कोशी में क्या है 1/pi into 1 plus x minus theta whole square. We are finding the at the f of xi. So f of xi is nothing but theta. So wherever the x, where we have to write the xi, and wherever the xi, we have to write the theta. So that is how we have written 1/pi into 1 plus x की जगह पे मैंने क्या लिखा थीटा, तो थीटा माइनस थीटा, आगे तो थीटा था ही x माइनस थीटा होल स्क्वायर. ठीक है,
यस सर.
तो x की जगह पे हमने क्या रखा थीटा. So that theta minus theta whole is cancel out. ठीक है.
यस सर, यस सर.
So I'll try to connect through mobile. Okay. My screen visible to all of you? Hello?
No, sir. No, sir.
Sir,
Okay. Okay, now I think it is visible.
Yes
Yes.
sir.
Okay, so your question that you have asked, why I have theta minus theta square? Because f of x is nothing but 1/1 plus 1 plus x minus theta whole square. Okay, and here it is a pi. So x की जगह पे मैं क्या थीटा रख रहा हूँ. I'm writing theta. So it is a 1/pi 1 plus theta minus theta square. So this is 0. So it is a 1/pi. Okay.
Yes sir.
So now then we proceed for the am I audible? Hello.
Yes sir. Yes sir, you're audible.
Yes, sir.
Okay. So there is another theorem that is called sampling distribution arising from normal distribution. Let x1, x2, xn be random sample drawn from normal distribution with mean mu and variance sigma square. And let sample mean is defined as x bar equal to 1 upon n summation xi, and sample variance s square is nothing but 1 upon n minus 1 summation xi minus x bar whole square. Okay, then we wish to prove x bar is asymptotically normal with mean mu and variance sigma square by n minus 1 s square upon sigma is distributed as chi square with n minus 1 degree of freedom. Further, we wish to show that x bar and n minus 1 s square upon sigma square are independently distributed with each other. Okay. So the proof is that to start this proof, we first write the joint density of x1, x2, xn. We know that xi are normal with mean mu and variance sigma. Then joint PDF of x1, x2, xn is constant into e raised to minus half 2 sigma square summation xi minus mu square. Okay, so how will you write this joint PDF? F of x1, x2, xn is nothing but product of, because they are independent, so it is a product of margin. And f of xi is nothing but 1 upon root 2 pi sigma into e raised to minus half xi minus mu I whole square. Okay, so these are the outside, so you can write it as a 1 upon root 2 pi sigma raised to n, and these are the product, so you can write it as a minus half of summation iron from 1 to n xi minus mu I whole square. So I call them as a constant c, and this quantity I have written here. Now we have seen the orthogonal transformation, so we are using the same concept. Let us make orthogonal transformation from x1, x2, xn to y1, y2, yn, such as y is equal to bx. Okay, and we consider the B matrix as whose first row is 1 upon root n, 1 upon root n, up to 1 upon root n. And rest of the row are orthogonal to the first row. First row. Okay, so we have seen that if x are normal, then y's are also normal, because y is a linear transformation of x. So they are orthogonal. Also, we have said that x transpose x is equal to y transpose y. Okay, so now we write here y is equal to bx. That is, y is nothing but y1, y2, yn, and this is the B matrix. This is the x1, x2, xn. Now, what is the first element? The y1 equal to 1 upon root x1, 1 upon plus 1 upon root x2, plus up to plus up to 1 upon root n xn. So that can be written as a x1, x2, xn upon root n. Is it clear? This is in this way. this is nothing but y1. That is what written. So root n is denominators. It is a common. So we can write y1 equal to this. But this is nothing but nx bar. Okay, same this side. So this root n will be cancelled out with this. So it is a y1 equal to root n x. And further we know that y transpose y is equal to x transpose x. That means summation yi square is equal to summation xi square. Okay. So what we can write for this, summation I running from 1 to yi square. Okay. Suppose I wish to write I running from 1
सर आपका माइक ऑफ है.
So you can write in this way. This is the way you can just obtain the simplification and you will get this quantity. And this quantity is nothing but we know that it is a n minus 1 s square. Sorry. Okay. So that is called n minus 1 s square. Now we wish to find out the distribution of this n minus 1 s square. So I am writing I running from 1 to n xi minus mu square is equal to summation xi square minus it is a 2 time mu n x bar square. Why n x bar square? Because summation xi is n x bar and plus n mu square because mu is repeating how many times? N times. So summation xi square I can write as a summation y square. And what about the nx root nx bar? I can write it is a y1. So here I can write it is a root n x bar and root x bar equal to y1. So I can write this y1 2 mu root n as it is and n mu square. Now I will 1 y outside. So I can write it is I running from 1 to 2 summation I run from 1 to running from 2 to n y square plus y1 square I am writing here it is y1 square not yi square minus this. Okay, so now I can write this as a y1 minus root n y in root n mu square and this is summation y square and this is you call them as a root n minus 1 s square. Later on we can now then the joint PDF. So wherever we have this substitute this. So we can write e raised to minus half sigma square y1 minus n mu square into or you can set it into नहीं लिखना तो minus e raised to minus 2 sigma square summation yi square where summation is running from 2 to n. Okay, so it show that if you are told, because they are independent, if you write in the form of the product also, if you don't want to write in this exponent minus, you can write it this exponent of this. So this is one quantity, this is the another quantity. So it is showing that y1 has normal distribution with mean root n mu and variance sigma square, and this show that all y1 y2 yn's are normal 0 sigma square. Why y2's are normal 0 sigma square? बताइए. क्योंकि आप यहाँ पे क्या कर रहे हैं, एक्स आई माइनस एक्स बार, एक्स आई माइनस एक्स बार, एक्स आई डिस्ट्रीब्यूशन हैज द मीन 0 एंड वेरिएंस क्या है, मीन म्यू एंड वेरिएंस सिग्मा स्क्वायर. ठीक है, तो यहाँ पे एक्स बार का आपके पास क्या आ गया, so y1 y not the y1 but y2 up to yn has the normal with mean 0 and variance sigma square. So what is the y1? Y1 has the is nothing but root n x bar is distributed as a normal root mu sigma square. So what is the distribution x bar? X bar is nothing but normal. You just root n by x bar upon root n. Just divide the root n. So what is that? It is expectation of x bar. Okay. So what is the expectation of x bar? I'll show here. We have given that root n x bar is distributed as normal root n mu and variance sigma square. That means expectation of root n x bar is equal to root n mu. So what is the root n is outside, expectation of x bar is equal to root n mu. This is cancel out. So that means x bar has the mean mu. Now what is the variance of root n x bar? We have given it is a sigma square. If you take this outside, so it is a root n square is outside, it is a variance of x bar, and that is sigma square. So this is n variance of x bar sigma square. Therefore, variance of x bar is equal to sigma square by n. Therefore, x bar is distributed as normal with mean mu and variance sigma square by n. Okay. So what is the distribution of x bar minus x bar? Sorry, if xi has the normal with mean mu and sigma square, what is the distribution of xi minus x bar? Anyone? It is a normal, and the mean of xi is mu, and x bar is also mu. So mu minus mu is 0. And what is the variance? What is the variance? Anyone? You can find out variance.
n minus 1 upon n into sigma square.
Very good. So it is a variance of x1 or xi. Okay. Minus it is a variance of x bar. This is nothing variance of a sigma square. This is nothing but sigma square upon n. It is a n sigma square minus sigma square upon n. It is a n in n minus 1 sigma square upon n. Okay. Is it? यहाँ पे प्लस आएगा. फिर -2 टाइम्स आएगा कोवेरियंस बिटवीन एक्स आई एंड एक्स बार, तो क्या आएगा? लेट अस प्रूव variance of xi minus x bar is nothing but variance of xi plus variance of x bar minus twice of covariance between xi and x bar. Now what is the variance of xi? It is a sigma square. Variance of x bar is sigma square by n minus twice of covariance xi. ये क्या लिख सकते हैं? समेशन xi by n. इसको बाहर ले लो n को, and this summation is outside because they are independent. So covariance between xi and xi. Why? Because तो यहाँ समेशन भी नहीं आएगा, क्यों? क्योंकि यहाँ पे x1 x2 x3, तो x1 का x2 के साथ 0 हो जाएगा, x1 का xn के साथ भी 0 हो जाएगा, तो बचेगा क्या? xi. This summation there is no need, okay, because they are independent, because covariance between xi and xj is 0, I not equal to j, and this is nothing but the sigma square plus sigma square by n minus 2 by n. This is covariance of xi. Xi is nothing but variance of xi, and it is a sigma square. It is a sigma square minus sigma square upon n, and that is how it is n minus 1 upon n sigma square. Okay. So what is the one upon n minus 1 summation xi minus x bar square? If this x bar minus x bar is distributed as a normal with mean 0 and variance is, what is this? Sigma square upon n into n minus 1, is it? That you have to verify. Okay. So what I'm saying here, let us say this has the normal distribution. We have given that yi's are normal 0 sigma square, okay, and yi's are normal 0 sigma square. Why yi's are normal 0 sigma square? Because you can write this as this way, y2 minus 0 whole square minus 1 by 2 sigma square. और एक में आएगा ना, इसका मतलब क्या? y2 का डिस्ट्रीब्यूशन मीन क्या है? 0, एंड वेरिएंस क्या है? सिग्मा स्क्वायर. दैट इज हाउ इट इज रिटन. एंड फर्दर y1 y2 yn आर इंडिपेंडेंट, यहाँ से पता चल रहा है. तो x bar has this distribution, y upon sigma is nothing but normal 0 1. So what happened? The yi square upon sigma square has y square upon sigma square has chi-square with 1 degree of freedom. So how many y's are there? So we have a 2 to n, it is n minus 1. So summation iron from 2 to n y upon sigma whole square is nothing but has the chi-square distribution with the degree of freedom is the sum of the independent chi-square variate. How many? N minus 1. So that is how the degree of freedom is n minus 1. Now what you can write by summation yi square from I ring from 2 to n, that you can write as a this quantity as this, and this is nothing but n minus 1 s square. So that is how you can write it is n minus 1 s square upon sigma square has the chi-square. And we have also shown that y1 and y2 yn are independent. So of course the x bar, it is a function of y1, and the function of y2 yn are also independent. So these are nothing but the sampling distribution. To prove this theorem, which transformation we had applied? Orthogonal transformation. We have required to know only the first row. The rest rows are orthogonal to each others, and we have used the property of the orthogonal transformation is that if x is a normal, then y is also a normal, and x transpose is equal to y transpose y. By using this, we have obtained, first we write the joint density and then apply the orthogonal transformations and then obtain the form of y1 as this and summation y2 square as this. Just substitute into this particular summation xi minus mu square is equal to this quantity. It is giving that y1 and y2 yn up to y3 yn are independent. So then we find out this has the distribution normal, then y1 equal to this, so we can obtain the x bar has this distribution. That is, sample mean is also distributed as normally with mean mu and variance sigma square by n. And yi upon sigma has the normal 0 1. So we know that if they are normal 0 1, the square of the normal is nothing but the chi square. So it is a chi square with 1 degree of freedom. But because the y2, y3 up to yn are independent, so we use the additive property of the chi square distribution, that sum of independent chi square is also chi square with corresponding sum of the degree of freedom. So it has the chi square with n minus 1, and summation y square we have shown that iron from 2 to n, it is n minus 1 s square, so n minus 1 s square is also chi square. And because y1 and the y2 yn are independent, so y1 and some function of y2 yn are also independent, and y1 has a function of x bar and this has the function of y2 yn, so they are independent. And that is what we have proved. Any questions? Anyone? Up to this, anyone? Any questions?
No, sir.
No, sir.
So let us have a